Alright lads, in this video I'm going to go through some basic things you'll need to know in relation to question 5 and question 6 in higher level. The first thing is going to be the ellipse question. So I've told you in chat already that you're going to be given where you're going to have the distance from your centre to your major, and you're going to be given your 2 focal points, and you'll be basically missing your minor. So what you need to do is draw on your major circle, like that there, and take your line down to the centre, and what you need to do then is very simply work backwards as opposed to what we usually do. So we're going to be taking our major, so half our major, swing it from our focal point, and that'll give you your minor axis. So just to show in colour there. We're going to be taking half our major, that distance there, and we swing it from our focal point to give us our minor. So that distance there is the same as that distance there. And that's how we find our minor circle. And with that then we're able to draw our ellipse as normal. So very simply just getting our 30/60 set square. And then taking all of our points on it. So here are all our points then that we need just to draw this ellipse, for example. So I just took just random measurements for this. Obviously in the question you'll be given them. There's our points there, and then just very neatly drawing a nice neat freehand curve. And then you can just go over it heavy then after that. So after that you'll either have to do one of the following. You'll either have to find a point, or sorry, find a tangent to a point on the curve. So for example, if I was to take a point there, I need to draw a tangent to that. Or if I told you you could draw a tangent to a point outside the curve. And let's just say we take that point out there. What you need to do is, for a tangent to a point on a curve, you connect your point to your focal points, and you have an angle in between. When you bisect that angle, so taking a random distance in your compass, swinging there and there, and you can stretch your compass out and swing a distance from there and there. Where they cross, join them back, and that line there is your normal. You always know what your normal, it's always going to go perpendicular to your tangent. So if I just slide my set square along there, go 90 degrees to it, you'll see that my normal touches the ellipse at one point there then as a result. To do it to a point outside the ellipse, what you need to do first is take the distance from your point to your first focal point, that distance there, and swing an arc like So a random length as far as around. You can draw a full circle if you want, just take a random length like that there. Then take the distance on your major axis, so take that length there and swing that from the furthest focal point. And you'll cross the arc there and there. So remember, for the first one, take this from the point to the nearest focal point. So the nearest one was F2 for me on this side. If I was going from this side, it would be F1. Because it's here, I swing it to F2. Then I take the length of my major and swing it from F1. Where they cross, you get 2 points. You connect both points back to F1. There and there. So connect it back to the furthest one. And where they cross, they're going to hit the ellipse here, for example. And that'll give you sorry, hit it here. Looking at the wrong point. Hit it here and here. So when you connect that point back to F1, it'll touch the ellipse here. And when I connect this one back, it touches the ellipse here. So not to be confused with the arc you drew first. That arc is just drawn to find these 2 points here and here. And then you can see you get a tangent there. And you get a tangent there. And there are 2 tangents that touch off a point outside the ellipse. So that's what you'll need to know for question 6, and obviously you're going to have a parabola as well, and you all know how to draw them already. So for the other part, I'm just going to pause the video, and then I'll show you in relation to rotations for question 3. Right, so lads, in this part of the video I'm going to go through how to do rotation, for example. So we've seen so far in the exam papers, there's one method where they're told you to rotate about a line L, for example. So it could be a line going at an angle and you rotate it around until it hits that line. We did that in 2019 question. In other years it can come up where what we did in class before, I just want to give you a recap on it, where we're told, for example, it rotates clockwise 90 degrees and you need to figure out that position then, and you're just given the point. So from P to P1 it rotates clockwise 90 degrees. So the first thing you need to do is you need to obviously determine what way is clockwise. Is it going this way or is it going this way? And we obviously know clockwise we're going to be rotating in this direction here. So we're going to be drawing our triangle that actually fits it so we can see our rotation. So the first thing we do is we join P to P1. We then need to imagine, will the top of the triangle be on this side of the line or this side? If it's rotating clockwise, we want to be swinging our arc from here around to here. So obviously we can't have our point on this side. If we have it on this side and we swing an arc, it's going to go this direction, it's going to go anti-clockwise. If we point out here and stick our compass down, we'll only be able to go this way. So that's how we determine it. We know it's going to be on this side. And we know it's also based on an isosceles triangle. Reason being, you'll see in a minute, I first of all bisect that. So I'm going to be drawing my isosceles. I bisect that, I get a distance there, going all the way along, and somewhere along there is going to be the top of my triangle. I told you it's going to be rotated clockwise 90 degrees. So in a triangle, I'll just do it down, let's do it over here so you can see out of the way. There's 180 degrees in a triangle. If we're rotating around 90, and we take 90 away from the 180, that's going to leave us with 90 degrees. For an isosceles triangle, the base angles are going to be equal. So we need to divide that by 2. That'll give us 45 degrees for each side, and that'll give us 90 in the centre then. So what I need to do is then get a protractor and take my 45 degree there and my 45 degree there. join them together. That angle there is 45. That angle there is 45. Most importantly, that angle there at the top is 90, the actual angle of rotation. So if we can move from this point to this point, we can see there we've moved at an angle of 90 degrees. We've also went clockwise. And another reason being why it's an isosceles triangle is this is from here to here in our compass. It needs to be the same as from there to there to actually meet the point. So we need to remember, no matter what angle it is, we take it away from 180 first. So for example, this one's 90. We then divide by 2 to give us our base angles for our isosceles triangle. Remember, isosceles, 2 base angles are the same, 2 side lengths are the same. That means we can use our compass to rotate it. And then to prove it then, if I start here and rotate P around, P goes to P1 there. And it's moved 90 degrees and it's also went clockwise. So from here around, it's moving clockwise and it's went 90 degrees from this point here to this point here. Just let that focus there for a sec. Next thing I'll do is start picking some of the points on it that I want to find out. So for example, I want to find this point here now. I'm just going to call that A. I want to rotate A now 90 degrees clockwise. First thing I'll do is I'll connect A to my centre. I'll rotate A around just like that there. What I want to do is I want to go 90 degrees from that edge there. So I can set my protractor down like this. There's 90 degrees. And where that line hits my new arc, there's the new position for A1. I can do the exact same with this one here. There's B. Sorry, first thing I'll do is just connect them again. Connect B there. Rotate B around. Same idea. It's rotating 90 degrees. Go to that line there that includes B to P. There's my mark for 90. Take that line out. It's B there. There's B1. What I can also do now, just actually get it going, is draw in my circle that's actually going to include all of them. So you can see I have A there, I have B there, and I have P in the centre. You can see that A1 connects to B1, B connects to P, and then I need this point here and this point here, so I can call that C and then call this one D. So just use a bit of colour for what I did up to now. I'm basically drawing similar triangles all the time rotating. So my first triangle would have been this one here. Having my 90 degree rotation there. The next one I had then, to show it in yellow, I would have connected A there. I would have measured 90 degrees to get A there. And then this angle here is also 90 degrees. This length is the same as that length. This length is the same as that length. And then to show them once more, with B, let's do it in green this time. And from there to there, then 90 degrees. And basically every single time, them two lengths are the same. And that angle there in green was also 90 degrees. So obviously you wouldn't do that in your exam colouring all that in. I'm just showing you exactly what I'm doing each time. I'm drawing triangles that have their top angle always at 90 degrees, and these lengths are always going to be the same each time. So just repeating the process over and over again. So for my next one, you'll see that C and D are actually going to pass through each other there for this one, just by pure coincidence. So what I can do is, I can rotate D around there, take C around as well. I'll just mark it there that I know this one is going to be C here. I don't get confused with that one. Get my protractor again. Go up to my line. Measure 90 degrees. And take that line out. D is on this one here. It's there. C is on this one here. So just follow that around. Gives me that point there. And just for the sake of it, I just draw this in heavy there really quickly. That's heavy between there and there. D is this point here. C is here, and you can see D connects to A. C connects to P. And now you can see I've rotated that around 90 degrees clockwise. So it's turned around until it's 90 degrees clockwise. And that's the angle you're going to get then. Your shape's going to look like that, just in colour. So you can see it. Red there. My shape was this. There's nothing wrong with doing this in the exam, so you can see it because you'll have a load of lines on your page by the time you're finished your questions. That's my shape, rotated around 90 degrees. You can basically see there, would have been standing upright like that, and now it's turned on its side there 90. But most questions, your shape will be kind of tilted in some way at some stage before you actually start this. I just started off with a random question in the book. Started off with a standing upright, and I said, right, I'm going to go from here to a random point out here, rotate 90 degrees. Could be 120, it could be less, but the exact same principle will apply each time. And it's based on this triangles method here, so you can see the yellow, pink and green triangles are all the exact same. They're all 90 degrees at the top, and the lengths on the side are determined by how far you stretch your compass out each time you're doing your points to rotate it around. So hopefully that video helps anybody who may have any troubles in understanding rotations, and also for the ellipse as well, and how to find your minor axis when given your focal points and your major axis, and then also how to draw a tangent to a point outside the curve and how to draw a tangent to a point on the curve.